Hi guys, how are you? Again, we're back to Calculus 2 classes. Today we're gonna solve 2 or 3 problems. We're gonna use different techniques to solve these problems. I need to follow me. These problems are long. You are actually in Calculus 2 and you have to understand that the Calculus 2 integration problems are a little hard and it needs a little focusing. What we are doing this, Calculus 2, solve integration problems with different techniques. Don't forget to like, subscribe if you like. Okay, let us go to the class directly because I need time. Then solve integration problem with different techniques. Now the first problem I'm going to start solving is integration of e to the 2x cosine 3x dx. Just one thing I need to mention for you. Can you listen a little bit? One thing I need to mention for you and for everyone. You can ask any question, okay? Now, when I have e and cosine, e and sine, this means for me integration by part twice. How many times? Twice. Now to make it easy and simple and quick, I'm going to call this integration I. To make it easy, look here. I'm going to call this integration, this form, I'm going to call it what? As I. This my integration is I. Why? Then because I know this goes twice, and this side of the board, I'm going to make small bar for me here. I'm going to choose u and choose what? U equal, for me, e to the 2x, u equal e to the 2x, du equal 2 e to the 2x. Now, dv equal cosine 3x. V, the integration of cosine is sine 3x over what? 3. Which is 1/3. Again, look guys, even you. Look what I'm going to do now. To say, because look here, because I know this integration, I have to do it twice. What I'm going to do, I'm going to use the second bar here, this here, as my nu, u, and v. dv. You go to the second step here, leave the constant, don't touch the constant. Don't touch the constant. Look what I'm going to do now, to make it easy. Now u equal e to the 2x du, because I have 2x here, 2 e to the 2x. Now, dv will be sine with no number. Look, I'm going to use only the sine. Sine 3x, and v equal integration of sine is negative cosine 3x over 3. Then I have all what I need. Bring me back to my integration. This I, we call it what we call it, guys? I equal. Do you watch me? John, okay? Look here. Watch, look. I'm gonna call it all this I. Okay. UV, you remember the formula. UV minus integration of V du. UV, sorry. U, what's u? E to the 2x, right? And I have 1/3 here, right? Then 1/3, look here, 1/3, 1/3, 1/3, 1/3 comes from the 3 here. Just the 1 here. You see that, guys? 1/3 e to the 2x sine 3x minus integration of v du, v du, v du, v du, this and this, right? We have 2 here and 3 here. 2/3. I can't take the 2/3 out. I'm gonna take the 2/3 out. 2/3 integration v e to the 2x sine 3x. Because I'm ready here. You see that? I'm ready for the second part. Okay, this I equal now 1/3 e to the x 2x sine 3x minus 2/3 bracket uv. What I have, guys, here? Negative 1/3 again, right? U and v. Look here. 1 here. And negative 1/3, right? I'm gonna put it in red. Negative 1/3 e to the 2x cosine 3x minus which one? uv minus v, the same thing. uv minus what? v du. v du, right? v du, this guy, right? Which is, we have 2 here, right? And negative 2/3 integration of e to the 2x cosine 3x dx. You follow me? You follow me? You see that? Now, uv negative 1/3 e to the 2x cosine f minus 2/3 e to the x cosine 3x dx. Now, this guy, what we call it? What we call this guy? I, right? You remember the I, we assume here I equal 2x. Look here, 2x cosine x. Look to this guy, cosine 3x, and this guy. Okay, I. Good. Then, just simplify. I equal 1/3 e to the 2x sine 3x minus, different color, okay, minus plus 2 times negative 1 2 3 times 9 e to the 2x cosine 3x. Here negative and negative is positive, right? These two negatives. And we have negative here, 4/9 I. 4/9. Again, you see this? Negative and negative. This 2 negatives is what? Positive, right? And we have negative outside will be what? Negative, right? Not positive. This is going to be, you fixed me, thank you. Again, the 2 negative is positive with this negative I. The I, this integration. And I have here I and negative 4I. Move this to this side. Becomes I plus 9I, which is my integration, the I, equal 1/3 e to the 2x. I'm going to take it as a common factor. 1/3 e to the 2x left sine 3x plus 2/3 cosine 3x. Now what you need, plus c, don't forget. Now just fix this guy here. This 1 over 1 times 9 times 9, 13 over 9, I equal 1/3 e to the 2x sine 3x plus 2/3 cosine 3x plus c. Multiply both sides by 9 over what? 13, right? Multiply both sides by 9 over 13. Multiply by 9 over 13, and here 9 over 13. Let me just move the equal sign a little bit here, and the 9 over 13 will be in both sides. 9 over 13. Okay, this cancel and this cancel. I equal 9, this cancel this, 1, 3 I mean, and this one, then 3 over 13 e to the 2x sine. Whenever you multiply the c, the constant by a number, still c. I don't care, still c. It's still constant. Inside sine 3x 2/3 cosine 3x. Okay, good? Good. Now, if you have any question about this, okay, I will, if you want me to email you these answers, the PDF, just, if you want me to email you the PDF, just let me know. Okay? Now, the second problem. Second problem we need to solve, which is, I have two problems. Cosine theta integration example, integration of cosine theta over sine squared. I did it in two different ways. I did it to my student. I'm going to do it in a different, complete way now. He will get some shock from the way I'm going to do it. Either we're going to fight with Mr. John or no, I don't know. U equal cosine what? I mean sine theta, right? Let us get U equal sine what? Theta. What's du? Du equal what? What du equal? Cosine theta what? D theta. Solve for d theta, for this guy, d theta equal du over cosine theta. Bring everything back here. Integration cosine theta and d theta here equal du over cosine theta, and my guys in the bottom, it's u squared plus u minus 6. You have two ways to do. This time I'm going to do it in a way, because I'm using techniques of integration, different techniques of integration. What do you think, John, we can do with this? 1 u squared plus u minus 6 du. Which way you can do this? Let me just tell you. I'm going to use now, you're going to get shocked. I'm going to use partial fraction. It's easier for me. Don't get mad because I let you use different way.
Come on, man. You need to do the hard way.
Okay, I know that. I said you're going to get mad for him. But let him do all the way. Let him be. This equal. Look, this is equal. Guys, 1 over. Factor this guy. Factor it. U plus. I'm sorry, let me just
U plus 3 and minus 3.
This plus u.
U plus 2.
Plus u. which is u. Okay, he's saying u plus 3,
No.
u minus what?
No. It's
You know this, Ayman? You know this? The factoring of this? See, we use it factoring here in advance. Now, we can split this one. We're going to do partial fraction. Then my method here is what? The first one by parts. Integration by what? You see the method? That's what I did. Pi parts, right? Different method. Here, I'm going to use partial fractions. Partial what? Partial fractions. Different methods, right? Oh my God. After the class, you can do whatever you want to.
Talk to you, bro.
After the class, no.
Feel bad.
I know you're gonna be mad with me. Now we're gonna split this one. U plus 3 plus b over u minus 2. This is why we teach. I mean, why the idea of teaching is to let the student know all the methods. Don't let him do the things he knows. There is no teaching if I give you something you know, right? I have to give you something you don't know. Right? Am I right with this?
Yes.
If I'm going to give you something we know, then there's no meaning for the teaching. Look what I'm going to do now, guys. For partial fraction, if you don't do... I did this for... Look here. I advise everyone watching me. I did on YouTube a full class about partial fractions. Did you watch it, John? About partial fractions.
No.
Okay. I have a full YouTube class about partial fractions and how you can, we call it decomposition. What we call it? Decompositions, right? To break it down. This is me. This guy here, look, this guy here, which is this square, the same as this. This is A, B, and this inside, u minus 2, you see? This guy to make it easy, and this guy here is what? U plus 3. And here we have, this side is only 1. I'm gonna give you easy way to find what's A and what's B. Look how we find what's A. We have two roots for this guy. The first root is u equal 2. U equal what? U equal 2. When u equal 2, the one stays 1. A stays 1. But when you put 2 minus 2 is here going to be what? 0. And here is going to be what? 5. This is going to be 0. And this is going to be what? 5. Then 1 equal 5b. Then b, because that I told you, wait with me to see what I'm going to do, right? It's worth it, right?
Yeah.
Plus, I'm not using your time. I'm very fair, right?
No.
The second one, after we use u2, we're going to use u equal negative 3. Why negative 3? Because I have plus 3 here. That cancels this. Then 1 stays 1. A stays A. I'm sorry. A stays A. And B stays B. And we know B is 1/5, right? We know B is what? Now we're using the 0 because we're using negative 3, and this is going to be what? 0. And this is going to be negative 3 minus 2, negative 5. Negative 3, we plug it in the equation here. Always we plug here. Okay. If you solve for A equal negative 1/5. Now my integration, back to my integration, I have A1 and B, right? Then my integration here will be equal to the sum of these two integration. I'm going to do 2 steps. A over u plus 3 du plus b over u minus 2 du. Now since A and B constant, since A and B both constant, I can take them out of my integration. 1 for A, negative 1/5 integration of 1 over u plus 3 du, and for b is 1/5 the b plus 1/5 integration of 1 over u minus 2 du. And this is very well known integration. When you have a linear inside and the derivative of this guy is 1 and the derivative of this guy is 1, which is in the top, then we have negative 1/5 ln, to protect yourself, u plus 3 plus 1/5, to protect yourself, ln u minus 2, and everything plus what? C. Okay, bring u now. From the beginning, u is equal to what? U equals
Sine theta.
sine theta, right? U equal sine theta. Then my final answer will be negative 1/5 ln. Okay, what you? You said sine theta
Sine theta.
plus what?
3.
3 plus 1/5. But anyway, you use it the same. And then next time, I will show you a different way to solve this problem, like what John did. Okay, now I have to change you, right? U to be sine theta, right? Am I right? Here, we have to change u to be what? Sine theta. Minus 2 plus c. Which way you like better?
That one.
And you like the first way for by parts? What I did for by part? Because I'm gonna just quickly go to this problem. I need to remember, John, since you see any e and cosine, e and sine, look what I did in this side. U equal e, the exponential du, right? dv, right? Then this for the first, this you do it for the first part because you need to do the integration by part twice, right? Now when I went, I did this again with the second part. Look what I did, the trick here. When I take u, is u the same, right? But when I take dv, the second one, right? I ignored any constant. I ignored all the constant. You see the 2 and the 1/3? I don't apply them here. I apply only e to the 2x and sine 3x, okay? Because they are constant. Then guys, I think that's good for the day, right? I wish for you a nice practice in doing calculus problem. Give me 1 minute, please. Just please, guys, if you have any question, let me back to my my email. If you have any question, don't hesitate to contact me at these. Text the problem. You can text me this phone number, or you can email me at this email number. I will be more than happy to help you. If you like. If you don't like, it's up to you. And subscribe. It's up to you if you want to subscribe or not. Thank you, guys, and have a nice day.